Hello, grade 11 here, Mr. G, and in this video we are going to be talking about the different types of intermolecular forces. Okay, so let's start by remembering or recalling that intermolecular forces are the forces between the molecules. So it's the force that keep one molecule hold to another molecule. It's outside the molecule, okay, not the bonds. So let's first of all start listing the different type of intermolecular forces that we are going to be doing here in class. Okay, so the first one is going to be related to ions, and is going to be called ion-dipole forces. Okay, this is the first one, and you can see here that we have ions involved. We will later on speak about ions. That is just the first name of the first force we are going to be talking about. The second force is going to be called ion-induced dipole forces. Ion-induced dipole forces, and once more we have ions here involved. Now, these are the only two types of forces that we are going to have ions involved. Okay, now remember what are ions. Ions are charged atoms. Ions are charged atoms because they either lose electrons or gain electrons, and these ones are coming from ionic substances. So ions form ionic substances, and if you break ionic substances, it will be broken into ions. So this is important to know for the video, for the rest of the question when we explain each of the different type of forces. Okay, so now these two type of forces are related to ions, as you see there. So we're going to have molecules and we're going to have ions involved. Okay, the third type of force is now not related to ions anymore. This one is called dipole-dipole forces. It's going to be only about molecules. It's called dipole-dipole forces, and there is a special case which you're going to write it here at the bottom called hydrogen bond, which we are eventually going to speak just about hydrogen bond. Okay, but this is the third name of the third force that we are going to be talking about. The fourth one is going to be called dipole-induced dipole forces. That is the important thing. Is 4. It's the number 4. It's going to be called dipole-induced dipole forces. And the fifth one, the last one, is going to be called London forces or induced dipole forces. Now, the induced dipole forces sometimes is also called London forces or dispersion forces. All this is names for induced dipole forces. We can use either of them. Most of the time we're going to use London forces. Okay? And now note, all these ones here, all these forces here belong to a group of forces called van der Waals forces. Van der Waals forces, I'm sure you can pronounce much better than I do this surname. It's van der Waals forces. So dipole-dipole forces, dipole-induced dipole forces, and induced dipole forces, all of them belong to this group called van der Waals forces. Okay? And we're going to be talking about those forces. In this video, we are going to focus on the first two groups, ion forces, and then we'll make another video related to van der Waals, because I don't want to make the videos too long and this one needs a little bit of explanation. Okay, so let's go to the first force called ion-dipole forces. Now, this type of intermolecular forces will generally happen when ionic substances are dissolved in polar solvents. Okay, so ionic substances are dissolved in a polar solvent. So ionic substances, remember, are coming due to the ionic bonding. For example, could be a sodium chloride, sodium iodide, etc. I'm not going to give you all of the ionic substances, but if these ionic substances are dissolved in a polar solvent, now the polar solvent is going to refer as the molecules, polar molecules. Polar molecules. So in other words, this ion dipole forces is going to happen between ionic substances and polar molecule, between ion and polar molecules. Now, what is going to happen? Those ionic substances, when they dissolve, they are going to dissociate. They are going to break into ions. Let's see one example quickly. Let's see the example of sodium chloride. When sodium chloride dissolves in water, it will dissociate. It will break into ions. It will break into sodium positive and chlorine negative. It will break into ions. And you can see here, these are the ions we are talking in the name. These are the ions. So when these salts, when these ionic substances dissolve in a polar solvent or in any solvent, they are going to be broken into ions. Now, these ions are going to interact with the polar molecule. Remember, a polar molecule is a molecule that has two poles. So, let's assume that sodium chloride is going to dissolve in water. Water is a polar molecule. So, let's just write here the water molecule. Okay. Here we have water molecule on the right hand side. So you know, we already learned about polar molecule, we learn about water specifically. We know that this side here is going to be slightly negative, and all this side here is going to be slightly positive. It doesn't mean that it's negative and positive. It means that it's a little bit more negative and the other side is going to be a little bit more positive. So what is going to actually happen when the sodium chloride dissolves in water? Okay, so let's do a small drawing here so you understand. So what is going to happen? We have here the sodium, the ion. It is being broken. Remember, the sodium chloride was broken into ions. So the sodium, which is positively charged, is an ion positively charged, will be attracted by the negative side of the water molecule. Remember, is the side with the oxygen. All this side here will be positive. So the negative side of the water molecule or the polar molecule, remember I use water as an example, but it's any polar molecule. Sorry, this one is negative here, so slightly negative, and then it's positive on all these sides. So the polar molecule, whatever molecule it is, as long as it is a polar molecule, will be attracted by the positive ion, and the other way around, the positive ion will attract the negative side of the molecule. So there will be forces between that negative side and the ion, and that is what we call ion-dipole forces. This here is the ion-dipole forces. It is formed between ion and a polar molecule. So what will happen to the other ion, the negative one, it will happen very similar, but the other way around, because the other ion is now going to be negative. So here, the negative ion chlorine will be attracted by the positive side of the molecule, and that force is what we call ion-dipole forces. Okay, ion-dipole forces. So I hope this is clear. This is the ion-dipole forces. It will happen generally where a ionic substance like sodium chloride will dissolve in a polar solvent. We're talking about polar molecules here, like for example water. It could be any polar molecule. So in order for you to identify the type of the intermolecular forces, the first thing you have to do is to identify if the molecule is polar or non-polar. So let's go to the second one, and that is going to be ion-induced dipole forces. So the first thing is to see when the ion-induced dipole forces is going to form. Now this one will happen generally when an ionic substance, and we already spoke about ionic substance right here, so we don't have to repeat what we said here. The video otherwise will be too long. We spoke about ionic substance, and we spoke how ionic substances dissociate, okay, how they break into ions, and these ionic substances are mixed with a nonpolar solvent. Now we must go to nonpolar solvent. Now nonpolar solvents are going to be the nonpolar molecules. This is the nonpolar molecules. Remember, we have a video on polar and nonpolar molecules. You can go and watch the video. Okay, now let's see one example so you understand how this is happening. For example, in the formation of iron oxide. So what is happening? You have an ion of iron which is positive. For example, you have iron, like I said, this is an ion. It's a positive ion, and the word is funny, is ion 1 plus, okay? And we have here oxygen molecule, which is a nonpolar molecule. And let's assume that this oxygen molecule and the ion molecule come into contact. Oxygen is, or ion burns in oxygen, and they come to form ion oxide. So what is going to happen? We have a positive ion and we have a nonpolar molecule. This positive ion will attract most of the electrons from this molecule. So the electrons here in these molecules are going to shift towards the left. It doesn't mean that all the electrons are going to move. Remember, they are not really going to move. They are going to shift a little bit. So all these electrons will move somewhat towards the left hand side in this case, and this molecule will temporarily become a polar molecule, which is induced by the ion, the positive ion. Okay, so it will be something like this. You can see here that as the ion come into contact with the oxygen molecule, all the electrons attempt to move to the left. They shift it to the left, and then this molecule temporarily become slightly more negative on this side because it have more electrons towards that end, and slightly more positive toward this side. When this happens, the force of this ion, of this positive ion with the nonpolar molecule, become an ion-induced dipole force. So this positive ion is making the molecule of oxygen, which is nonpolar, to be polar. And this force that keeps them together is called ion-induced dipole. This is happening between ions and nonpolar molecules. I hope it's clear. It's a little bit tricky, but it's not that difficult. Anytime you have an ion, please remember I use Fe plus, which the name is the same as ion, but we are not referring to Fe plus. It could be Na plus, it could be any other substance which is an ionic substance. Okay, so if you have an ionic substance that is mixed with a nonpolar solvent, that force that keeps those substances together is called ion-induced dipole. I hope this one helped. We're going to stop here. We later on will make another video related to the other type of forces, the van der Waals, but this one I think is already 14 minutes, so we must stop right here. Thank you for watching. I hope you understand. You can always let me know if you understand. Thumb up if you think the video helped. Thank you very much, and good luck.